So we know about the circle of fifths, but what happens if we do a circle of sixths? This is gonna be so dumb. How about the circle of minor sixths? Circle of minor sevenths? Circle of major sevenths? Let's do the circle of tritones. That'll be short. We're done. Same with the circle of major thirds.
You can't keep getting away with it!
Hello. I'm not actually on a crusade against Charles Cornell. I just saw that video and I thought, well, we can actually have a circle of thirds, so how many other interval circles can we have? So before we carry on with the video, please hit the like and subscribe buttons. Every time you do, I get a little bit of serotonin. It's not about channel growth, it's about my happiness. So please do it, please. Let's start with your common, humble circle of fifths. Now there are loads of videos out on YouTube on how to use the circle of fifths and that explain it really well. And there are many ways that you can use the circle of fifths, or many ways that you can represent it, like this one that I've already spoken about in a previous video about non-bijective voice leading. Maybe you're the one that puts the fourths on the clockwise side, and maybe you should stop doing that and get some help. But I'm not here today to explain, your regular old circle of fifths. I'm gonna give you the little secrets about it. Today we're going to talk about axes. Now, axes on the circle of fifths are how you invert scales, say for, well, scalar inversion, chordal inversion, or negative harmony. Now for this I'm just going to pair it with pitch class space as well, which I'll explain a bit later on. So there are a total of 12 axes of inversion, 6 root axes and 6 intervallic axes. So first we're going to look at the root axes. So our first root axis is C and F sharp, or 0 and 6 on pitch class space. Our second being C sharp and G, 1 and 7 on pitch class space. D and A flat, 2 and 8. E flat and A, 3 and 9. E and B flat, 4 and 10. F and B, 5 and 11. And here are the 6 intervallic axes. The 5th or flat 2 axis, which is 3.5, the 2 or flat 6 axis, which is 4.5, the 6 and flat 3 axis, which is 5.5, the 3 and flat 7 axis, which is 0.5, the 7 and 4th axis, which is 1.5, and the tritone axis, which is 2.5. Now we can simply just use these to transform melodic lines and harmonic voicings to use in our songwriting. Now let's see an example of that. Say if we use this melodic line over a 2-5-1, perhaps we can use its inverse over the 5 chord to create a more tense sound, and we do this by flipping it over its 5th axis. Of course, this is relative to the scale that we're working with. Say here we're in C, so the 5th axis for C would be G, but if we're in other keys, say B flat, then its 5th axis would be F. My mind's gone fucking blank, Jesus Christ. I haven't woke up yet. Dear. So if we want to invert a chord, say we take our C major 7 chord. Flipping that over its 5th axis would give us this chord, which gives it a bit of a G Phrygian modality. Next.
Circle of major sevenths.
So this is what is called pitch class space, or the chromatic circle, or the circle of minor seconds or major sevenths. Historically, this is used to analyze atonal music, serialism, your good old normal regular pop music. Furthermore, this is used to visualize relationships between pitch and interval classes. This also makes it easier for us to visualize transposition. Say if we take pitch class number 2, which is D. If we transpose this Y1 semitone, we just add 1 pitch class to it. It's pretty simple. But we can also do this for sets. So a set is a collection of pitch classes, like a chord. If we do this for a whole chord and we just add 1 pitch class to each element of the set, then we can go from C major to all the way to C sharp major. Using the axes that we discussed earlier, we can use the pitch classes of those axes to provide a more mathematical approach for inversion. Say if we use a C major scale, we can use a function of 2x minus y, x being the inversion point and y being the pitch class that we're going to transform. We also use mod 12 here to keep it all in the same octave. So if we were playing this C major 9 arpeggio over a 2-5-1 with a pitch class set of 0, 2, 4, 7 and 11, we can invert it around the 5th axis to get a pitch class set of 7, 5, 3, 0 and 8. So we can play its inversion over the 5 chord to give us a more tense sound. Next.
What happens if we do a circle of 6 and minor thirds?
So, the circle of thirds. This is why I made the video in the first place. So from what I've seen, there are a few representations of the circle of thirds, but this one is my personal favourite because it shows you parsimonious voice leading between diatonic chords. As you can see here, we only need to change one note between each chord in the key to get to the next chord, which is a third away. We can also use this circle to use parsimonious voice leading between 7th chords, shown here. See, this is a really handy way of getting to know all the triadic and 7th chord inversions in a more musical way, and it helps you get used to voice leading between chords in a particular key. You can also apply this to chords outside of a key by using parsimonious voice leading between different chords in different keys. Next. So now the only interval that is really left is the tritone, a circle of tritones. So this really got me thinking. So because you can't do a circle of tritones in 12-tone equal temperament because it will just go from C to F sharp to C again, then I thought, well, how about the 11th harmonic? After an hour of research, an hour of crunching numbers, I had achieved something that no man should ever set out to achieve. I had made a monster. God forgive me. So how did I make this monstrosity? And how can we use it? Well, for the second question, I have no idea. So on the inside of the circle of tritones, you'll find the pitch classes related to each of the notes. But on the outside, you will find the note names generalized to within the nearest quarter tone. So the 11th harmonic is 551 cents away from our fundamental of C. This gives it a pitch class of 5.51. So essentially all I did was add the 11th harmonic to the 11th harmonic, and then added the 11th harmonic to the 11th harmonic's 11th harmonic, if that makes sense. And using mod 12, I made sure that they all fell under the same octave. This is still a generalization of the 11th harmonic because it's only to 2 decimal places, and I'm generalizing the note name to within the nearest quarter tone. So by the end of this, as we get back to C, we are about a comma out of tune, so this means we have achieved a comma pump. As there are 24 11th harmonics in this circle, I've had to map it onto a icositetragon. So yeah, I have no idea how to use this because it's not within the constraints of 12-tone equal temperament. Somebody else might know how to use it, just not me. I'm not that guy. Next.
Circle of minor sevenths.
I'm not doing this. I'm not doing the circle of ninths because I would end up doing it the same way that I did the circle of tritones, which I'm not going to do. But we could do it by using the value of 2.04 and adding that onto our fundamental, because that is its interval class in the harmonic series. So by the time we do one cycle, we'll again be 24 cents out. And as it wouldn't include all the chromatic pitches, I'd just want to keep going until it does, and that would take too long. So I'm not going to do it. No, thank you. Oh, well, I believe that's everything. So like and subscribe, I guess. Have a lovely day.